Hi, you're all welcome back to today's class. We'll be looking at equivalent fraction. Equivalent what? Fraction. What is an equivalent fraction, or what are equivalent fractions? They are those fractions that their values are the same irrespective of having different numerators and denominators. When simplified, their values are what? The same. Let's look at these numbers for a clearer picture. Let's look at 6 over 12 and 4 over 8. Are these numbers actually equivalent? Let's solve and see. Now, 6 and 12, what can divide the two without a remainder? Remember what we do in the numerator? That is what we'll do in the denominator too. So, 6 can actually divide itself to give us 1, and 6 can go into 12 twice to give us 2, right? So, we have 1 over 2 for 6 over 12. Then 4 over 8. 4 can divide itself to give us 1, and 4 can divide 8 to give us 2. Same 1 over 2. What does that tell you? It tells you that the two of them are what? Equivalent. They are equivalent when simplified. After we simplify them, the answer gave us 1 over 2. Let's look at these two fractions on the board. We have 9 over 12 and 6 over 8. Irrespective of the different numerators, here we have 9, here we have 6, and the denominators 12 and 8. When simplified, are they going to give us the same value to make it equivalent in nature? Let's find out in this number 2. Now we have 9 and 12. What can divide 9 and 12 without a remainder? Let's go for 3. 3 can divide 9 to give us 3 because it will go thrice. And 3 can also divide 12 to give us 4. So we are going to have 3 over 4 there. What can divide 6 and 8 without a remainder? We use 2. Because if we use 3, 3 can divide 6, but 3 cannot go into 8 without a remainder, right? So we are going to use 2. 2 going into 6 will give us 3, and 2 going into 8 will give us 4. Are they actually equivalent in nature? Yes, they are, because the first one gave us 3 over 4, and the second one also gave us 3 over 4. When simplified, they are equivalent. So this is also an equivalent fraction. Did you see it? So you find out that all equivalent fractions are reduced to the same simplest form. As in, when we reduce them, they give us the same number, just like the two examples we have done before now. Now, let's look at this fraction on the board, number 3, 12 over 20 and 22 over 30. Are they actually equivalent in nature? Let's solve. In this particular one, we are going to use two methods for us to know whether these two fractions on the board, whether they are equivalent or they are not. First of all, we are going to use the first method by finding out the LCM of 20 and 30. We want to, in such a way that the two denominators are going to be the same thing. What we have here is what we are going to have here. We're going to first of all make the two denominators to be the same. Now, the LCM of 20 and 30 is 60. But let's do it this way for us to know what we actually did. Let's do it by the side. We'll have 30 and we'll have 20, right? What can divide these two numbers without a remainder? We are going to use 2. 2 going into 30 will give us 15. 2 going into 20 will give us 10. What can divide again? We use 2 because we're having 10 there. 2 here will still bring out our 15, and here will bring down 5. What we use 3 because of this 15 here. 3 going into 15 will have 5, and then we'll bring out 5 here. Then we'll have 5 as the last prime number. We'll have 5 here, 1, and 5 here, 1. So how do we get the LCM? By bringing out these ones, 2 times 2 times 3 times 5, which will give us 2 times 2 is what? 4. 4 times 3 is what? 12. 12 times 5 is 60. So the denominator, the LCM for the two denominators is now what? 60. So we have actually gotten a denominator for this and this, right? Now, what do we do to the numerator? we are going to actually, what we do down, we do it up. So here we are going to have 12 over 20 multiplied by, now 20 multiply what? We give us the new denominator, which is 60. That's 20 multiply 3. So we are going to have 20 times 3. And here we also have 12 times 3, because what we do down, we also do it up. So 20 times 3 will give me 60, right? And 12 times 3 will give us what? 3 times 2 is what? 6. 3 times 1 is 3. So we are going to have here 36 over 60. Now let's do number 2, the second fraction, which is 22 over 30. Remember, we use 3 here. 30 multiply what will give us 60. That's the denominator, 60, which is 2. So we are going to use 2 up and use 2 down. 30 times 2 is what? 60. And we'll have 22 times 2 is what? 44. So looking at these two, 36 and 44, are they the same? No, they are not the same. That makes it automatically that 12 over 20 and 22 over 30, they are not what? They are not equivalent fraction. We also have another method we can use to find out whether they are actually equivalent fraction. Let's look at that number, that method. Let's still do look at the method. Over 20, 22 over 30. Let me bring it down so that it doesn't confuse us. That's second method. This second method, we are going to use cross multiplication. We have 12 over 20 and we have 22 over 30. 12 over 20, 22 over 30. When we cross multiply, we are going to have, see what I mean by that? We have 22 over 30. When we cross multiply, we are going to have 20 times 22, which is what? 20 times 22 all over what? 12 times 30. Or you do 12 times 30 to be in front and 20. So now 20 times 22 will give me what? 20 times 22 will give us what? We have 220 times 2, which will give us 440 all over 12 times 30. We put our 0 here, which is 120, multiply it by 3. 3 times 0 is what? 0. 3 times 2 is 6, and 3 times 3 is what? 3 times 1 is 3. So you see that 440 and 360, are they equivalent? No. So it actually shows us that 12 over 20 and 22 over 30, they are not equivalent fractions. Now, this number 4, we're going to look at complete the pairs of equivalent fraction. Remember, we are still solving for equivalent fraction. Let's look at this. We have 1 over 9. 1 over 9 is it equal to, there is a dash here, all over 27. Or let's put it as a box, all over 27. 1 over 9 is it equal to a box all over 27. We want to find out whether they are actually equivalent. Now, how did we get 27 here? What can you multiply by 9 to give you 27? That is 3, right? 3 times 9 is 27. So automatically what we have done down, we will do it up. Since 3 times 9 is 27, we are going to now do 1 times 3 is what? 3. So we are going to have 3 over 27. So 1 over 9 is equal to 3 over 27. Let's look at number 2. We have 3 over 4 and dash over 28. That's number 5 here. 3 over 4 is equal to a box over 28. Like we actually did in front, as in number 4 above. What can I multiply by 4 to give me 28? What number can I multiply by 4 to give me 28? That's 7. 7 times 4 is 28. So we'll do 3 times 7, which is what? 21. So 21 over 28, they are equivalent in nature, because when I reduce it, I'm going to come back to 3 over 4, right? Now let's look at this number 6. 3 over a box down here is equal to 5 over 9 over 15. This time around, they did not give us the denominator, but the numerator is present. So we are going to look at the one that have the two numbers there, right? So we'll have 9 here and 3. 9 multiply or 9 divide what will give me 3, because we are going from the bigger section to the smaller one. So it is division now and not multiplication. 9 divide what will give me 3. That is 9 divide 3, because 3 times 3 will give us 9. So we are going to also divide 15 by 3. 15 divide 3 will have 5. So here we have 3 over 5 is equivalent to 9 over 15. Hope you are really enjoying the class. If you have followed us to this point, please do well to subscribe to our channel, and so you can get more notifications. Let's look at these fractions on the board. This is number 1. Remember, I wrote activity. Automatically, you're the one that is going to do this for me. We have 6 over 9. Is it equal to 36 over 54? Number 2, we are going to have 48 over 96 over 96. Is it equal to 45 over 90? Number 3, we are going to have 13 over 65. Is it equal to 26 over 78? This is a question mark. You're going to attempt these ones, and I want to see the answers in the comment. You actually tell us if they are equivalent or they are not equivalent with all the methods we have learned today. Hope you really enjoyed today's class. Bye-bye.